Hey guys, welcome back to the channel. Welcome back to the Futura Tomahawk Aviation assembly / build series. This is video number 2 in the series. Before we get into this though, if this is your first time finding the channel, don't forget to hit that subscribe button, give the video a thumbs up, and if you have any questions or comments, make sure you list them down below. If you guys have any video ideas, what you ask for, your video ideas are extremely helpful with future videos. So please list them down below, or you can contact me via email. Alright guys, so in this episode we are going to be focusing primarily to begin with on the turbine installation. So we're going to get the rear elevators installed, and then we're going to work on the fuel system, installing the turbine and things like that. So without further ado, let's hop in. Alright guys, next thing we're going to do is work on the elevators. If you hear that buzzing in the background, that's my new power supply from RC Powers. Wicked little power supply, 12-24 volts. And this thing has enough juice to finally power my Hyperion 720i charger. So very excited to have that. Just got that today. Anyway, so as discussed, we are going to work on the elevators and then the turbine. Now, because we have these connections, and I'm not sure if I'm gonna keep this long, so I'm not going to do up my servo ends on these connectors yet. But fortunately, we've got awesome plugins right here that we can just plug into the receiver and get these servos centered. So that's the next step. I just got to look through all the parts over there and figure out which servo horns and connecting rods and stuff. And then we're going to get each of these servos and servo horns and rods set up. And then once that's done, we're going to install it on the rear of the plane. Alright guys, so with the 28X we've got a little bit of setup here to do. This kind of applies to any radio. So a couple things is we've got just the basic wing setup, so we haven't gone in and done anything with that. So let's go in and we'll do a couple things. So throttle channel, we need to reduce that to 100. So that's done. And then what we're going to go in and do is we're going to go in and set the wing type. So we go to the wing type diagram, and let's set up our wing. So we've got, let's see here, 2 ailerons, 2 flaps, tail, we've got 2 elevators, 1 rudder, throttle, we've got 1 throttle. So now when we go to the monitor screen, we should have right elevator, left elevator. So I needed to do that just so we knew which channels were which. And now what we're going to do is we're going to plug in the right elevator in channel number 3, and we're going to install the servo horn and make sure the direction is proper. So just a tip here for you guys. So we've got 2 of these red servo horns. And I originally put the other one on first and it didn't line up properly, so I switched them out, and this one lines up perfectly, almost at a 90-degree angle, without adding any sub trim. So just a little note, make sure you're trying to get that as much of a 90-degree angle as possible without adding sub trim. Alright, so that's what we're looking for when you're setting up something like this. We want our arm to be 90 degrees, we want obviously the servo to be, or the surface to be centered, and we're all good there. So we've got lots of travel as well. So that's too much travel, but that's max travel right now, and she works good. So we'll repeat the same thing on the other side. Alright guys, elevator is all installed. It went together very well. Basically the one side plugs in, the right side plugs in, and then we just do up those 2 screws that were already done up on the other side. So that is all 100%. Now we will have to get rid of the, as I talked before, the double plug-in for the wing. And the reason for that is because it was set up as an SBus setup. So we had 1 input for the wing with 2 SBus servos. So now we've got to have individual servo leads going to the wing, which is no big deal because we've got a nice little outlet there. It's just 2 more connections now that we need to do. Previously it was 2 connections, but you had to plug them in there. So So that's something we're dealing with. Now, moving on to the tank and the plumbing setup. So I can't take this tank out because the vent nipple comes too high, but that's okay. So I just pulled all the fuel tubing off of the vent fitting, pulled the bung out, and this is what we have in there. So it actually is appears to be working very well. The tank is dry on the inside, but when I blow out on the tube there, this actually still contains fuel after this long. So we're just going to keep that as is. I'm just going to check and make sure that this length is sufficient. But if it is sufficient, we're just going to put new tie wire on these. And the tie wire, those single wraps, I'm not a big fan of. So I'll show you guys what I do for the double wrap. But first I'm just going to check the length on this guy. Alright guys, so we're going to pull this existing tie wire off. I'll do this one after. But here's how I do the double lines. So just take a piece of tie wire. I'm not stingy with it, so I've always got lots of excess tie wire. And so we just wrap it around twice. Just like that. And I know there's a tool for this. I've never gotten the tool, so I use a little pair of forceps, the locking kind. Okay, and I just grab that about maybe a centimeter, 1/4 of an inch away, and give it some twists. Then all I do, give it some more twists. If you go too tight on this, it's going to actually snap the tie wire. And I cut it off. So we've got a little bit left over, and then just bend it over. Now usually just a little picky thing that I do is when I'm bending it over, I will bend it towards the non-important side of the tube. So what I mean by that is I don't want this little pokey end on this side possibly creating a hole. It'll probably never happen, but that's just one of those details that I always pay attention to. And so that's how I do the tie wire. And then I'm going to do the same thing on this side. Alright guys, so we're all set up there. Now, one thing with these metal bungs is you want to make sure you're not using Loctite on the threads. And all you need to do is use silicone oil. Okay, so silicone oil, this is shock oil for RC cars. Doesn't react with rubber parts. That's why they use it in plumbing, silicone grease, things like that. So we're just going to put a little bit of silicone oil on there, and we'll thread that into the tank. Alright guys, fuel tank is set back in place. We're not screwed in yet, but it is in place. So we've got the bung installed there. The top one is marked with an F. That one's marked with an X because it's not doing anything, so that's our fuel line. So we need to organize all that stuff. Next thing we're going to do is we're going to install the engine. So first thing we have to do is install those two plates that we had installed before. And once those are in place, and we'll be able to bolt the engine in. It looks like we are missing a blind nut, so I'll try and see if we have that kicking around somewhere. But we're going to get the plates bolted in, and then ideally the engine bolted in. Okay, so because this engine was installed previously, everything's kind of stuck in its current place unless we change something. So what I've done is I've put the plates back in, laid the engine in place where it's roughly going to sit. And we want to do a couple things here now. Number one, we want to check the centering of the turbine within the pipe, and then we also want to check the pipe distance. So that's the distance from the end of the tail cone to where the pipe begins. Now I see this being asked quite a bit as far as pipe distance and stuff. Always check with the manufacturer's manual, but a good normal number is 1 inch or 25 millimeters from the end of the tail cone to where the pipe begins. Now you're not talking about the bell mouth, you're talking about where the actual pipe itself, the flat piece, begins. Okay guys, so if you look at the centering of the turbine, hopefully it picks it up on camera, but that turbine is sitting a little bit low, and it's pretty easy to tell just visually looking at it. You can see the exhaust. You're not really looking at the exhaust cone, but it's the ring around the exhaust cone. I can see more of the turbine on the top of the pipe versus the underside of the or the bottom of the pipe. So that turbine needs to be raised up or our pipe needs to be dropped a little bit, is what we know as a step number 1. So when we look in there, there's not a lot of room for pipe adjustments. What we will do though is I just push down on the bell mouth to see if we can get any sort of movement out of that pipe, put the turbine back in, and see what we're up against. Okay, so we're close, but didn't really do anything to the turbine, so we do need to raise that turbine up, probably about 3 to 4 millimeters. So in this particular situation, I think the easiest way to do that is we're going to put some shims in between the plywood on the engine rails and the metal mounting tabs of the turbine. So in that case, we'll just use some ply shims, some wood shims. That is the length of the rail, and that's going to be the easiest way to raise that engine up. So when it comes to measuring the distance between the end of the tail cone and the beginning of the pipe, that's what I have this long dowel for. That's basically my pipe measurement tool, so disregard that first mark. What we're going with is this mark right here, the bigger mark. So what I do is I lay the rod inside the pipe, and I just get it lined up with where the pipe begins, and then I put a mark on the dowel. Next thing I'll do is line up or touch the dowel to the end of the tail cone, and now we can see the distance between the pipe and the tail cone of the turbine. So in this particular case, that's where we're at. I'll just grab my calipers so we're official here. But in this case, we are 24 millimeters, which is within the acceptable range. 25 would be 1 inch, so it's really, really close, but we'll keep it where it is. We don't have to make any adjustments there, but just figured I'd show you guys that just to make it easier. If you're trying to do it from this end, obviously measuring that space is very difficult. I found that the dowel system is definitely the easiest way to do it. Now, if you do run your turbine further in, further out, that does change power settings, cooling settings, lots of different things on the turbine. So we want to try and get it within that manufacturer's spec, or roughly about 1 inch. 25 to 30 millimeters is kind of the norm that I see. All right, guys, so this is what we're going to do as far as the turbine, raising the turbine goes. So I've got these 2 plywood plates. I don't know yet if these are the right size, but what I'm going to do is just temporarily install these underneath the turbine, and then we'll check the turbine spacing, looking through the back again as well too. These are probably about 5 millimeters thick. Just measure them to check. And yes, I do own digital calipers, but sometimes these things are easier. So we're looking at about 4 millimeters thick. So we'll install those and see what it looks like. All right, so you can see there I've just placed them underneath the turbine. Now when we look at the turbine now, we're not worried about side-to-side spacing because we're not lined up with the holes. We're just worried about up and down. Okay, so now when we look down that pipe, we can see a nice even space on the top and the bottom, and it's a nice spacing. I think that's going to be perfect. That's exactly what we're looking for. Now, if you don't get that turbine centered, what can happen is, in this particular case, the turbine was sitting too low, and you've got more of the exhaust hitting the bottom portion of the pipe, less of the exhaust hitting the top, so that can create hot spots in your pipe, which could cause a premature failure. It's just not a good situation, so it is very important to get that turbine nice and centered within that pipe. Okay, so all we're going to do now is take one of these plywood spacers. One of the holes already lines up well, so we're just going to use that one as the centering hole, and then we just put the other ones in there with pen. So we've got the right one marked, we've got the left one marked, and we'll just drill out those holes. We'll be able to put these plates in place and then bolt down the engine. All right, guys, engine has been bolted down. Looked at the engine through the rear, and it looks good. Now we've got a little bit to do here with the plumbing. So I put the the vent fitting on the side here, and I like that spot because it's easy to access. If you want to use a taxi tank with this fitting, you can just put the taxi tank on top of the wing or on the ground. Works good, nice and easy to access. So that's where I put it, and it's a nice short run here to the vent line on the tank. So for that, I've used 6mm festo tubing, which is the biggest tubing size in this entire fuel system. Now, when you look at the way this fuel system is currently set up, basically we've got the UAT or the bubble trap tank right here. Now the line coming out the front is the feed line for the pump. So that one goes directly up through the on-off valve, and then the on-off valve out to the pump, which is right over there, the inlet on the pump, and the output on the pump comes back to the turbine, which we're going to switch because we're going to change that fuel filter out for a different one because those Festo ones are not good in this situation. So this fuel system has been working fine the way it is. There's not big runs here. It's a 140 Newton turbine, but it's also a very fuel efficient turbine with this Jets-Munt turbine. So I'm going to keep everything the way it is. Generally what I would do is I would up the size going to the intake of the fuel pump. But because we have a Festo fitting here, we are fairly limited in what we can do. So yeah, anyways, that's what we're doing. The main tank, we've got the one line which we have to blank off, and the other line which feeds the tank, the UAT right here. So when you're filling this, you're going to be filling it through, the way this plane was actually set up is it's going to be filling through this one, which I also don't like, so we're probably going to eliminate the ball valve. That was just used for filling. I prefer using a fuel dot. So we're going to change that out. But basically you fill through here, it goes through the back fitting on the tank, fills the UAT tank, comes out of this fitting, and goes into the main tank. When the main tank's full, the fuel comes out of the vent, and lastly comes out of the side of the plane. So that's how the fuel system works. So there's not a lot to do here. I'm just going to do the final setups. If I run across anything weird, I'll show you guys. But that's what we're doing for the fuel setup. And then once this fuel setup is done, I'm going to kind of jimmy rig the receiver setup, and we will fire up this turbine and see how she works. All right, guys, so everything's hooked up. You can see I added the fuel filter there. I put a Festo in line, so it's easy to disconnect that. So that's all run. We changed the filler line to a piece of Tygon, a small Tygon piece, and that we just used one of these adapters to 4 to 6mm adapters. And that's the fill line, so that's going to work good. So next thing I'm going to do is I'm going to just put this on a stand, open up the garage. We're going to have to set up the receiver and stuff to the turbine, so we'll get that done. And I'll just do all that stuff because it's fairly straightforward items that is all covered in the manuals. But I'll get that done, and then I'll show you guys. We'll do the first startup and cross our fingers. Hopefully it starts. All right, guys, so we're all plugged in on the plane. One thing I'm going to do is I got to change the throttle trim to be a 4-position trim tab, which is what I like to do. So I'll just show you how I do that on the 28X in case you are interested. So there's the throttle trim here, which is not what we want because it's actually throttle cut. So what we need to do is go into trim system. Okay, throttle, we want it to be I think I do this as 100. Yeah, there we go. So basically we've got 4 positions. So that's off and that's on. All right, guys, so before we start this turbine, we want to make sure we go through all the checks and balances, okay? So I hooked up the fuel filler to the airplane and started filling it. The UAT looks good, but this fitting right here, the 4mm to 6mm fitting, is leaking. Now, I'm not sure which side is leaking, but what I'm going to do is I'm going to just disconnect them, connect them again, see if that fixes the leak. If it doesn't fix the leak, then we'll have to go to a different solution. I'll have to check and see if I've got a spare one, or maybe we go to a permanent fitting like we used on the filler side. So I'm going to check that and see what we come up with. Okay, guys, so we've got some fuel in the tank. We did fix the leak there. What I actually did was take this back piece of tubing out, put a new piece in, and that fixed it. So it was just the old tubing that was in there. We primed the fuel line using the EC, or the data terminal. So now we've got fuel coming all the way to the turbine right there on the fuel fitting. So we're basically ready to go. So what we're going to do is we're going to start this thing, do a nice run up on it, and make sure that it works. Alright guys, so the last thing for this video is we are going to do some gluing. Now if you've watched my videos before, you know I like to get as much gluing ready as possible before I actually mix some epoxy or high sol up. So in this case we are actually going to use SBus System 610, which I just showed you in the previous clip. Reason I'm using this is because number one, on the gear plates here, we do need to get some epoxy in there and clamp those down. So I need something a little bit thinner, which this material is. And also I'm out of high sol, so I need to stop and get some. But we're going to use this stuff instead. Very, very similar to high sol as far as gluing performance, but looks a little bit different as well. It's more like a jelly appearance, but this stuff was a little bit lumpy, kind of like what high sol happens to high sol sometimes. So you just hit it with a heat gun and it gets rid of all the lumps, so it's nice and smooth, and it'll work good. So I'm going to get all the gluing laid up, and I will show you exactly what I glued. Probably mixed way too much here, but that's okay. All right, guys, I have to apologize. I did forget to give bent screwdriver its credit. That is clearly what I use to mix up all my epoxy and install the epoxy. So if you do not have a bent screwdriver, I highly suggest you make yourself a bent screwdriver. Definitely the most useful tool in my toolbox. It's awesome. Okay, so here's what we glued. Basically the front gear mounts required some glue. Now they were still in decent shape, but they were split. So I just basically shoved the 610 epoxy in there in the splits and clamped her down, and that should work beautifully. The 2 blue clips right here, the front mounts for the equipment tray had broken off. It looks like they were made out of basswood, and so I put some 1/2-inch ply, some aircraft ply in there. That's what I like to use for my blocks because it holds together really well. So I got 2 of those installed, and then there's little stoppers right here for this front tray to rest on. I guess the main equipment tray for starting and stopping. This side was good, but the other side was missing that little tab, so I just glued a piece of ply on there. So, all right, guys, that's everything for video number 2 of the Tomahawk Futura reassembly video. Got a lot accomplished in this video. Very, very happy that the engine runs successfully. That is definitely a win. This engine has been sitting now for at least 2 years, maybe longer, maybe a little bit shorter. I think we'll just say 2 years without being run. The engine total right now is 4 hours on it. So it's in great shape, runs amazingly well. Everything worked perfectly with the run. Very, very impressed with the Jets-Munt turbine the 140 that's in this plane. So, like with all my videos, guys, hopefully you got something out of this video. If you do have any suggestions for future videos, make sure you list them down below. Feel free to send me an email as well, too. Love to hear what you guys would love to learn more about. And what I do with your suggestions is I add them to my list. And if it's a new one, I make a new little note. And that will open up some options for some future videos when we're not doing builds or reassemblies or repairs, stuff like that. So that's everything for this episode, guys. If you haven't done so already, give this video a thumbs up, please. And also, if you're not a subscriber, hit that subscribe button down below. Helps to support the channel. And that's it, guys. Thanks so much for tuning into this video. We will see you in the next one.